Good afternoon, everyone. We'll be with you very shortly. We're just going to wait, see if the room fills up a little bit more before we commence. Good afternoon, everyone. Thank you for joining us this afternoon at the Ground Source Heat Pump Association's free webinar. We've got Dr. Jan Rosenow joining us today. Jan is the Director of the European Programme at RAP, which is a Regulatory Assistance Project. That's an independent organisation dedicated to accelerating the transition to a clean, reliable and efficient energy future. They've also advised governments on policy all over the world, and they've recently been advisors to the BEIS Committee on decarbonising heat. So Jan is going to talk to us about heat pumps in the context of the energy price crisis and net zero. Just to let you know, the webinar is being recorded and streamed live on YouTube. Could I ask kindly that any questions you have be put into the Q&A box, and we will go through these at the end of Dr. Jan's presentation. And without further ado, I'm going to hand over to Dr. Jan Rosenow.
Thanks, Stephen. I'm just sharing my slides. I hope you can see them. I believe you can. So I'm going to talk about three things, really. In the title, it only mentions two. It mentions the energy price crisis and net zero, but I'm also going to talk about the implications of the war in Russia for heat pumps, and then hopefully we have ample time for discussion later on. So those are the three things I'm going to tackle in the presentation, but I just wanted to start with a graphic which I looked at today on past heating transitions in the UK, and this shows the percentage of households with central heating systems in the UK from the 1970s, early 1970s, all the way through to 2018. And you can see that in 1970, only about 30% of homes had central heating systems. That was more than 90% by the early 2000s, and is now around 95, 96%. And the speed at which that transition was achieved is pretty remarkable. In the 60s, very few people had central heating. So that just, I think, should encourage us that rapid change in heating systems is indeed possible and has happened before in the UK. So that is, I think, actually a positive news story that we should keep in mind when you think about sort of future transitions. Let me now go to the first out of the three topics I wanted to talk about. Well, actually, there's a bit of an introduction, which is about the global heat pump market developments that we've recently seen before I come to that. This is based on analysis I've done for Carbon Brief recently with Duncan Gibb from REN 21. And we sort of looked at most recent data on market developments for heat pumps all over the world and selected a number of countries. And this is the post. You can see it online if you wanted to look it up and find all the data there and all the sources, etc. But the key findings really are that over the last sort of decade, heat pumps have grown quite a bit. The global heat pump stock has almost doubled. But if we project those growth trends to the 2030, and we compare that with what is needed according to the International Energy Agency to meet 2050 at global level, we are not quite there yet. We're not getting there. That is changing a bit now because this graph was based on sort of last year's data, didn't include all the data from 2021. So that is changing now. So what we're seeing is that, especially in countries that have the coldest climates, in Europe, for example, we have very high penetrations of heat pumps already. So you see here the average temperature in January over the last 30 years. And you see the penetration of heat pumps on the x-axis. So y-axis is temperatures, and the x-axis is the penetration of heat pumps. This is the percentage of households that have a heat pump. You will see Norway at the very right end of the graphic with about 60%, probably now more than 65% of homes with a heat pump. Also Sweden, Finland, Estonia all have high penetrations of heat pumps, but they're also the coldest countries. So that is an interesting observation, given that quite often we hear heat pumps don't work in cold climates, but very clearly they do. The second observation is that growth in 2021 has been absolutely astonishing in a number of places. Poland, of all places, is showing the highest growth figures that we have found across the world. There's still countries publishing data as we speak, but this is the latest available data. 60% growth in the heat pump market in Poland in 2021, but also Germany 28%, Finland 25%, Norway 36%, Switzerland 20%, and the US 15%. All very impressive growth figures. We don't yet have the official figures for the UK, but I believe the heat pump market in the UK has about doubled. So again, very impressive growth figures there. So now to my three topics. The first one that I wanted to tackle was what the war in Ukraine means for heat pumps. And this may not seem an obvious question, but it is. It's really triggered a very significant discussion about the role of heat pumps to phase out Russian fossil fuel imports, especially Russian gas, of course, but also oil, where we replace heating oil systems with heat pumps. And there have even been proposals that some of you may have seen that the US government could use the Defense Act to mobilize funding, mass manufacture heat pumps and ship them to Europe. So that's the kind of level of discussion that we're having. And I'm having a call with the White House later to discuss that. So we really reached, I think, a different level now with the discussion about heat pumps really picking up a lot of steam. Just today, there's articles every day in the media now, but just today, two pieces that cite some of the analysis that we've done. The Express, not the most likely outfit for this, but in this case, they have covered it, and The Independent both make the case that heat pumps and energy efficiency are actually the quickest way of reducing gas consumption from Russia much more quickly than things like fracking, because that takes a lot longer to actually deliver. So the discussion has really accelerated over the last couple of weeks, and I'm sure we can discuss some of that a bit later in the Q&A. Some of you may have also seen this report from the International Energy Agency. This came out, I think it was last week, and it's a 10-point plan for Europe to reduce its reliance on Russian gas imports. And you note that one of the 10 actions is to speed up the replacement of gas boilers with heat pumps. I know this is a Ground Source Heat Pump Association webinar, and the icon is an air source heat pump, but I think this point is generally applying to all heat pumps. And what the IA believes should be done is to double the deployment rate as fast as we can to achieve savings in Russian gas. And of course, then if you continue that beyond this year, those savings will be even larger. The European Commission have put forward a very similar plan as well that also involves a doubling of the deployment rate of heat pumps. How exactly they're going to achieve that remains to be seen, but the level of ambition is certainly rising quite rapidly because of those sort of policy initiatives that we're seeing across the world. And of course, also in again the media, this is Bloomberg. There is discussion now whether consumers could do something about their own impact on consuming Russian gas. So we have articles like this, which really speak directly to consumers and homeowners. And again, that is a change in the discussion, and I'm sure will drive more demand for heat pumps because many people ask themselves the question, what can I do specifically? I don't want to wait for sort of policy developments. I actually want to do something right now with my own home. So that discussion has really changed, I think, the way how heat pumps are being perceived and certainly being recognized now at the very highest level of decision making. This is a calculation I have done for the UK lately, where I have looked at how much gas is being consumed in UK homes, how much gas is being imported that is used for home heating. That's the middle bar here, the grey, colored bar. And what are the potential savings we could actually get if we switched from gas boilers to heat pumps, and if we installed more insulation. And you can see that we can certainly completely offset all the gas imports used for home heating. And we can not completely, but almost offset the gas consumption. The reason for that is that some gas will still be needed, at least in the foreseeable future, for producing the electricity that is needed for the heat pumps. That's why the two figures don't entirely match up. That gap is essentially the electricity needed for the heat pumps to run and using gas. But that's sort of the opportunity we have. And I think that discussion will continue for some time. Now, the second point I wanted to make is about energy prices. We've seen projections for the next winter for dual fuel bills in the UK potentially going up to as much as £3,000 per household. They're going to go up about to £2,000 in April. That's based on the Ofgem price cap. And of course, that is a huge increase in energy prices, and especially gas prices have increased by a very significant margin. I think they're now about 7 pence per kilowatt hour after the price cap in April, and that's forecasted to go up even further. Given where we've been a few years back when gas prices were around sort of 2 or 3 pence per kilowatt hour, that has really changed the economics of heat pumps. And of course, electricity has gone up as well, but not quite so much. So the gas prices are shown here. You just see sort of at wholesale level how quickly they have risen and to what kinds of levels. This is from a couple of days ago. I'm sure prices today are again a bit different, but this is from 2 days ago. And you can see that the wholesale level gas price is equivalent to about 24 pence per kilowatt hour. Bear in mind that is wholesale level, it's not retail. So once that is being passed on to consumers, certainly gas prices that will feed through are going to go even further up, as I said before. Electricity prices, as I said, going up as well, but not quite so much as gas prices. And the ratio between gas and electricity prices has changed fundamentally because of that. So the question that I asked myself a while back is, how does this change the running costs of heat pumps versus gas boilers? Because we have often heard in the past, and this is what has been largely true, that in many cases, you couldn't see significant savings with a heat pump, ground source heat pumps more so than air source because of the higher efficiency. But the running costs of gas boilers were so low that it was difficult for heat pumps to beat gas boilers on running costs. But this has changed as well. This is a calculation that I did about a couple of weeks ago that was widely covered in the media. And you can find the link. I can probably put that in the chat later if you want, with all the detailed assumptions behind that. What it essentially shows is the running costs of a gas boiler at 2 different efficiencies. You can pick the one you like. 92% efficiency is sort of what is expected theoretically of gas boiler performance when they're installed. 85% is closer to what they actually deliver in terms of efficiency based on field data. And then you can see the sloping sort of blue line going downwards. That's the running cost of heat pumps based on different coefficients of performance. I've considered here 2.5 to 4. You could extend that further to 5 if you want. And you would see that around sort of a coefficient of performance of 3, you're really starting to see savings to come in. And that will shift again in next winter as the ratio of gas to electricity prices will further change and make heat pumps more attractive. But that's, I think, an important message here, that the price rises have really changed the running costs of heat pumps very fundamentally, and there's now a situation where they can deliver real cost savings. Now, I wanted to talk a bit about net zero and what this means for heat pumps. That's the sort of third and final part of my presentation. Net zero, again, has really changed the discussion about home heating. Projections that are many, many years old now, that were based on sort of a 60% or 80% reduction of carbon emissions, often assumed still a significant share of fossil fuel heating in homes, often for the reason that it's easier to reduce emissions in the power sector, for example, and we can live with a remaining share of fossil fuel heating in homes and non-commercial buildings. Net zero has, of course, changed that completely, because we now need to eliminate emissions from the building sector almost completely. And therefore, we see a much, much harder push in all the modeling that's been done, but also the policies to ramp up low carbon heating solutions much more quickly. Here's data from the IEA, the International Energy Agency again. They have published a roadmap to net zero by 2050 in August last year. And according to the IEA, we will need 1.8 billion heat pumps globally by the year 2050. I think currently the stock of heat pumps globally is around 10% of that, maybe a little bit more. So we need to increase that by a factor of 10, which is absolutely massive. You can also see how this compares to some of the other technologies the IEA believe will play an important role here. District heat, and of course, some of that heat will also be produced by heat pumps, large-scale heat pumps, in particular, that are already used in places like Denmark or Sweden, but also some biomass, solar thermal, and a tiny slice of hydrogen. This is about 2% of total global heat demand for space heating, which the IEA believes will come from hydrogen heating systems. Similar analysis by Mckinsey actually shows very, very similar numbers, slightly different, but again, you see in light blue here, this is the system sales, the number of units sold in millions per year over time. And you can see in 2050, the vast majority, almost 90% of all new heating systems sold, McKinsey believe, will need to be heat pumps. So again, you see that different analysis comes to a very similar conclusion. Massive rollout of heat pumps will be required to meet those very demanding net zero goals. Nope. And that's all I wanted to say, really. And I'm looking forward to your questions or comments. Hopefully that was clear. And if you have any sort of questions, I'm happy to go back on the slides and provide a bit more detail. But I'm really looking forward to the discussion and wanted to leave ample time for that. So, Stephen, I believe you will hand me some questions now, and I will stop sharing my screen.
No problem, Jan. At the moment, we haven't got any questions, so you must have done a very good job of telling everyone about this. Just going to double check. No, we have no questions, Jan, at all.
No questions. That's a first. I've never done a presentation with no questions. There's one.
Oh, here we go. So what about ground source heat pumps for cooling and flexible electricity tariffs?
So there are two parts in the question, I believe. I mean, the first one is about flexible electricity tariffs. And I mean, I've used them, or I still use them myself, as an owner of a heat pump. I believe they have tremendous potential. We've seen the trials recently from National Grid with Octopus, where people could sign up to lower their peak demand. But we also had dynamic tariffs, for quite a few years now. And of course, they're nothing new. We had these kinds of tariffs, Economy 7 type tariffs, all the way sort of in the 1970s and 80s, not just in the UK, but in other places too. So I totally believe that that is the way forward. And using flexible tariffs with smart controls of heat pumps, both ground source and air source, can deliver more carbon savings, because we can avoid using heat pumps during peak hours when we have gas on the system and other fossil fuels, and use them more when we have more renewables outside of peak hours, and also get real bill savings for consumers. Before all the price increases, I could actually see my own running costs from when I have a gas boiler to having a heat pump drop by as much as 60%, simply by using a flexible tariff. I mean, that is no longer possible in the same way, because prices have changed, but clearly going forward, there will still be potential. The second part of the question was about cooling. And I think that's completely overlooked still, because of course, with the changing climate, and we see hotter summers, longer periods of very high temperatures, not just in the UK, but also in other European countries and in North America, the demand for cooling will go up. And we have not build, I believe, our homes in a way that is fit for purpose. We often build them to sort of keep the heat in rather than keep the heat out. And of course, with lots of glazing and no external shading, that will create problems further down the line. So there will be a demand for more cooling for sure. And I think we need to get the balance right between sort of more passive measures like external shading and using heat pumps for cooling as well. So clearly a role there for heat pumps. And I understand, of course, for an air to water system, that benefit does not exist, but for ground source heat pumps, that is different. And so clearly there's an important role there, different for air to air systems, which are widespread in other countries, especially in Scandinavia. Sorry, very long answer to a very simple question, but that gave me some opportunity to, I think, collect some more comments and answers and questions in the chat.
That's right, Jan. We've got quite a few now, so I will ask you some of these. What are the biggest barriers to that level of increase in deployment?
I think one big barrier is I talked about already. What used to be the running costs. I think for a lot of people, they just couldn't see a good reason, unless they were very strongly environmentally minded, to invest in a heat pump. That has changed already. So I think that barrier is now a lot less strong. The upfront cost, of course, is still an issue, especially with ground source, where there's a significant investment with the drilling and the borehole, but that, of course, will still be there for decades to come. So we need to find a way of getting that cost stretched over much longer periods of time. I'm sure many of you will be working in the heat pump industry. Clearly, the installer capacity that we currently have is insufficient. I think we have about 1,500 people in the UK who install heat pumps. Compare that to, I think it's about 150,000 people who can install gas boilers. So there's a huge gap between what we need, which I believe the estimate is about 45,000 trained heat pump installers are needed to deliver on what the Climate Change Committee thinks we need to do with heat pump deployment. So the workforce is still not there. So we need to do a lot more training, but also manufacturing capacity. I know there's lots of investment already, but talking to the industry, there are real constraints with specific components, such as semiconductors, that need to be made more available, and just the ability to ramp up more quickly and build more factories to actually produce the kit. So that's, I think, is a supply side constraint. And for consumers, I think once we get around the kind of cost barrier, then finding more streamlined approach of actually getting a heat pump installed. Who can I turn to? Who can I trust? I think that's also going to be really important, and making sure we have good quality installations. Looking at the history of heat pump deployment in the Nordic countries, they had real problems with poor installations in the early years, and that had a massive impact on consumer confidence. They managed to overcome that by really ramping up the quality of these installs, but it has taken them some time, and that's something we should get right straight away.
Thank you for that, Jan. An anonymous question here. With the government grant being included, it seems installers have just increased their prices. What can be done to bring prices down to pre-grant levels? Well, this is kind of a multi-dollar question, isn't it? It's one of the things that people always ask: how much will costs be able to come down? And BASE is currently doing a research project. They commissioned Eunomia to look into the potential cost falls of heat pumps, and they're doing the study as we speak. We're not going to see that, I think, for some time. It's going to take a bit of time for them to come out with their findings. So that should provide some guidance on how much costs could fall. The UK Energy Research Centre is doing the same at the moment. The evidence for that is very weak, to be quite honest. We have, first of all, very little data on past cost sort of trajectories in different countries. So it's hard to come by this data. And there are also lots of uncertainties. So I don't want to make a prediction, but I think once we scale up, given what we've seen in other sectors, we should see costs come down. I think right now, because we have supply side constraints, not enough installers, not enough capacity, and more demand, that's always what happens, is that then prices go up. But I think they should come down once the industry is scaling.
and we find more efficiencies in the way how we install heat pumps, but also how we manufacture them. But I can't give you a number, I'm afraid. I think the expectation the government has is 25% reduction, at least maybe 50%. But of course, the question is to what extent can that be delivered and by when? I know Octopus have come in with a very aggressive announcement saying they can bring down the cost to the same level as gas boilers with the boiler upgrade scheme grant that will come in April, but it remains to be seen whether they deliver on that. They say they will. And that's for air source only, of course, not for ground source. So sorry, long answer to a simple question, but the answer is we don't quite know yet, but there is some scope, I think, for optimism.
Thank you, Jan. A similar question on cost. When do you think the levies on electricity will be reformed and a carbon tax applied to gas? And do you have an idea of what those costs would be?
Yes, I mean, it used to be 23% roughly of electricity bills, domestic electricity bills were environmental levies. And the government in its heating building strategy in October announced that they would review whether or not to shift levies from electricity potentially to gas to have a more sort of level playing field and make electricity cheaper compared to gas in that way. I think that discussion has now changed a bit because gas prices are up so significantly as I've outlined. So it's a lot harder politically to put additional costs on gas. And of course, also because the running costs have now become more attractive, the pressure is less urgent to do that now. And the third factor is the share of levies of electricity bills has also gone down because electricity prices have gone up, but levies have stayed the same. So those factors, I think, point towards certainly not an immediate change, probably will take a little bit longer, but it's really hard to predict when that will happen. The government said they would review it this year. Whether or not that review will then result in a change is very difficult to say.
Thank you, Jan. Now, another question, and this one's from Dan Roberts. The figures you presented stated heat pump. Could you advise what the expected % split between ground source heat pump and air source heat pump may be?
Well, it depends kind of which projections you believe. Most of the projections assume a very high share of air source heat pumps. That's the case sort of globally, and that's what we see in most markets, that air source kind of dominates. It hasn't always been the case. I mean, when you look at historic market trends, there have been countries where ground source was a dominant technology because of the higher efficiency, especially in colder climates. But that has clearly changed. Even, and I didn't provide all the detail, but if you zoom in on, let's say, Norway or Finland, you will see most of the systems installed are air-to-air systems. Now, not air to water, not ground source, but air to air systems. So really, I think ground source heat pumps will have a significant role, but most projections don't think they're going to be the dominant technology. I think it also remains to be seen how the efficiencies of air source heat pumps improve, and to what extent ground source heat pumps can become cheaper over time. But yeah, there will be massive growth in both air source and ground source, I think, is probably the answer. But the kind of evidence I've seen points towards a higher share for air source systems.
Thank you, Jan. What about the future here from Ken Neal? Does demand side control play an important part in the future?
Absolutely. I mean, if we were going to add millions of heat pumps to the grid and not take advantage of flexible heating, it would result in higher costs, both for electricity generation, but also for grid reinforcement and things like that. So not doing that would be a lost opportunity. It could also result in lower customer bills. There was a question about flexible electricity prices. So we should absolutely do it. At scale, it hasn't been done yet. There are some pilot basically cases where this has been trialed. Dong Energy in 2011 did this in Denmark, and I think it was in Copenhagen, with a few hundred households, and they showed that you could reduce peak demand by smart controls, so smart automation of heat pumps by about 30 to 40%, and that could be replicated, of course, in other countries. I know that TenneT, together with, I think it's Fiesmann, German manufacturer of heat pumps and other heating systems, they're doing a pilot study which is underway. And of course, there's been modeling by the 4D Heat Project, I think in Scotland, National Grid and other partners to do the same thing. So huge potential, but yeah, we need to demonstrate that it actually works in practice for a very large number of households. And then we need to monitor very carefully what those impacts are. But absolutely, I think that is a massive opportunity for grid management. And it's a much better way, I think, if we always look at heat pumps as, oh, they're going to put lots of burden on the grid. Sure, they're going to require massive upgrades, but they can also be a tremendous resource when it comes to flexibility services.
Thank you, Jan. We have another one kind of looking forward to the future here. What is the landscape of heat pump device improvements and things related to regulations on handling refrigerants?
Well, that is slightly outside of my area of expertise. I've talked to people from the IEA who have done lots of detailed technical work. I think as part of there's an annex, a research annex of the IEA on heat pumps specifically, where they looked at refrigerants and global warming potentials and minimizing the impacts of refrigerants. They could give you a proper answer. I can't really. What I know is that there are now many more low carbon, lower global warming potential refrigerants in the market, and they become more economic. They're more widespread. But we still have a lot of systems that don't use them. I think it's less of an issue for monoblock systems, but that's where my knowledge ends, I'm afraid. But I'm more than happy to sort of refer you to the right people. If you email me, I can do that.
An interesting question from David Broom, and it's something I know our association's trying to tackle here. I think we have a communication/education problem, not a technology problem. As an industry, how do we change consumer perceptions of heat pumps?
Well, I think the first step has already been achieved, and that is that we now have a much higher awareness for this technology. I mean, there's been both very good and very negative press coverage over the last couple of years, but at least heat pumps are now being talked about, not just by the industry and experts, but also in a way that is more visible to the general public, and I think that's important. So that I think that's part of the communication challenge achieved, but clearly the advice piece and informing people about the potential for heat pumps to decarbonize their homes, but also to deliver sort of long-term cost savings. I think there's still a massive gap. When you go on sort of the common sort of websites giving you advice, they're often out of date. They're using old price figures, old carbon figures, and we really need much better, much more tailored advice that communicates the benefits of heat pumps more clearly, and also communicates clearly who do you actually turn to? How do you find a good installer? How do you make sure that you have a good experience? So I think that is absolutely critical, and I think there's a huge job that needs to be done, not just for the industry. I think this is something that everyone who works in this space should pay more attention to.
Thank you, Jan. Edward Robinson's asking, is a boiler upgrade scheme a better incentive than the RHI? And how have the energy price changes of the last 6 months affected this?
So the RHI is more generous, actually, when you look at how much money you can get back. And I'm sure many of you know this, especially for ground source heat pumps. Of course, that's an important factor because of the higher capital costs. I think the kind of downside of the RHI has always been that it's quite a complex financial product, and that the financial payments were made on a quarterly basis over, I think, typically 7 years or 8 years. So the upfront cost barrier was still the same, and people had to take out a loan or find some other ways of funding that. That is different with a boiler upgrade scheme, where you can get that money straight away. But it's a smaller amount. You're only getting, I think it's 5,000 for air source and 6,000 for ground source, I believe. With the RHI, you could get significantly more money, and clearly that is actually it's not an improvement on that front. But I believe the fact that it's upfront really will make a difference. So yeah, it's a bit worse in terms of the over amount of funding, but it's better because it's upfront. So think it depends how you see it. Probably better for air source and a bit worse, or quite a bit worse for ground source, I would have thought.
Thank you for that. James Brettel is asking, is there a list of target U values that we should be advising our clients to aim for, both when dealing with making improvements to existing properties and for new build properties, i.e. passive house values of the new Part L standard?
I mean, again, this is a common question that I get all the time. You know, what kind of buildings are heat pump ready? Which buildings should we focus on first? You know, again, there is no hard and fast rule, I think, that can be applied. I mean, one way of looking at it is, can you use lower flow temperatures? I think is a fairly reasonable approach. You know, can you actually heat the building with when you lower the flow temperature to, let's say, 50, maybe 55 degrees centigrade, to the same level, or to the level that the customer wants. I think that is a reasonable sort of compromise approach. I don't believe you need a passive house standard building to have a heat pump. In that case, actually, you might not need any you know, expensive heating system at all. You know, maybe even direct resistive heating in those cases might be cheaper and might be more effective. But on the other hand, you know, we don't want to put heat pumps into completely uninsulated buildings with single glazing, no loft insulation. So when people ask me privately, I always tell them, look, if your loft is not insulated, if you have single glazing, if you have drafty doors, I would not straight away install a heat pump. Fix that first. You know, that's not that expensive. Important question then is, do we need solid wall insulation? I have some of my walls insulated, but not all of them yet, simply because of the hassle factor and the cost involved and the disruption of that. So I think there's a lot of space between the passive house standard and very badly insulated buildings. But exactly how much of that is heat pump ready is difficult to say. The Committee on Climate Change believe it's about 40% of British homes could have a heat pump straight away.
Thank you, Jan. So an interesting question on ground arrays from Simon Lomax. If waste heat is diverted to a communal ground array and can bolster source temperature, is there any opportunity for split ownership with entities pre-installing the arrays, as there will be a greater efficiency advantage compared to air source heat pumps?
I would love to see that, and yeah, you could think about sort of models where, you know, different neighbors group together and they sort of share the cost of the infrastructure. That will actually benefit, you know, not just them, but, you know, sort of future owners, occupants of those buildings, and deliver a more efficient heating system for all of them. So I'd love to see more of those models in practice. I've seen you know, some of the thinking around it. It's not available yet at scale. Yeah, I think there have been some sort of pilot projects, but that's the sort of thing that we should be thinking about more. I mean, there are even more, I guess, sort of exciting projects that already have happened in other countries. One example is in Munich, where they have used sort of solar thermal to store large amounts of heat in sort of underground sort of thermal storage in the summer, and then extract it with a large heat pump in the winter, feed it into a very small district heating network, and put it back into the buildings. I mean, that is an even more sort of systems approach to this that doesn't just rely on individuals making individual choices. But that was for new buildings, I have to say. This wasn't for retrofitting. Thank
you. And now, something I don't know if you've experienced of, but I'm getting a few questions, a few comments here about supply issues in the EU. Have you heard about them in Europe as well? Just your thoughts on that, really, Jan. Yes, there are supply issues, and I've spoken to the European Heat Pump Association about this last week, because yeah, the IEA report on the European Commission saying we can double the installation rate. The industry actually doesn't think that is possible so quickly, you know, and that's for two reasons. One is that coming out of the pandemic, there's been a backlog of orders, I understand, and a lot of the suppliers and the installers are already you know, behind, and it's completely stretched and don't have capacity to ramp up so quickly, because they're dealing with that backlog. But also components. So I was told things like semiconductors are not available at the amount needed. So that's putting a real constraint in manufacturing heat pumps.
new factories need to be built. That takes a little bit of time. It doesn't take 5 years, but it certainly can't be done in a couple of months. So that's another constraint. And then again, installers. We need more installers who can do this well. We don't have them yet, so that's another constraint. So the numbers I've been given was sort of maybe get another 25-30% growth in across Europe, including the UK. This year, which will of course differ between different countries, but that's kind of for the whole of Europe, including the UK, and then growing at a faster rate afterwards, maybe 50% even across the European Union plus UK, as we ramp up that factory capacity and train more installers. But it's going to take a bit of time, and I think we need to be honest about that. We can't just say, oh, we're going to install 3 times more heat pumps this year. I think there are real constraints in a number of areas that we need to be aware of.
Thank you, Jan, for that. And just a question about data, and obviously I know you're very good on your data, Jan. And someone's asking here, Alistair's asking, are there any data about where in the UK heat pumps are being installed, and are there regional differences?
The data is surprisingly poor, actually. I tried to forward the piece I've shown you at the beginning, the Carbon Brief article. I wanted to get the recent figures for the UK, and I was told that there isn't a central place where this is being collected, which really astounded me, given that this is such an important strategic priority. And we really ought to have much better data on this to be able to not only answer the question, how many heat pumps of what kind have been installed, what kinds of efficiencies, coefficient of performance, but also where are they installed, in what kinds of homes, in which regions, which cities, and we just don't have that. Clearly Ofgem would have a lot of that data because of the RHI, and MCS would have some of that data as well, but there doesn't seem to be a central database in the UK. Clearly that's something BASE ought to look at, or the Committee on Climate Change ought to look at.
Thank you, Jan. Andrew's asking, what percentage of UK electricity generation is currently from natural gas? And do you see this reducing significantly ahead of the target of 2050?
It's about 40%. Of course, it depends on which year you're looking at. 2020 was a pretty good year for renewables. 2021, a little bit less. So it varies, but it's about 40% still is from natural gas. And the question is, how quickly will that come down? Again, there are sort of projections that we could look at, for example, the net zero strategy from the government. It's a bit difficult to say how quickly that will reduce. But coal is already at, I think it's less than 2% in the last year. So coal is almost out, and the last coal power stations are going to be phased out, I think, by 2024, 2023, I believe, in the UK, which really only leaves gas as the only fossil fuel for electricity generation in the mix. And as we ramp up wind and solar, which is already happening, and there's lots of investments in more offshore wind, for example, but also rooftop solar installations and industrial scale solar. So I would expect that to come down, but will it come down by sort of 5% or even 10%? I wouldn't want to predict that, but it will come down further. And by 2035, the kind of trajectory the government is working towards is to actually phase out all fossil fuels in electricity, pretty much all fossil fuels for making electricity, which of course is a massive challenge going forward. And the key there is really to solve the issue of dispatchable power generation, where gas currently fills the gaps. If we have no wind and no solar, gas comes in, and it's often the case, especially when it's sort of cloudy and it's cold and no wind. And that's when we need something else, and that can't just be wind and solar. We need something else that can fill that gap, which it could be hydrogen, it could for power generation, could be storage, but also some flexibility on the demand side. So it's going to be a combination of things.
Some challenges ahead there then, Jan, on that front. So an interesting question from Sophie, a bit of an environmental question here. To ensure net zero, we will need to reduce all emissions, not just CO2 emissions. With this huge projected rollout of heat pumps, how can we avoid a lock-in of high global warming potential, HFC refrigerant gases, and their associated emissions in these heat pumps?
Yeah, I think it's a really valid question, and it's about sort of embodied carbon emissions in heat pumps, which there is some good research on this. And when I looked at it the last time, there's a sort of peer-reviewed paper that looks at the evidence, and it shows currently those embodied emissions, including the refrigerant emissions and the leakage of those. You kind of offset that within a year and a half of running a heat pump because of the carbon savings compared to a gas boiler. But of course, in the context of net zero, that may not be enough. And I can only refer back to the IEA's work on this in the heat pump annex, which is about low carbon and low global warming potential refrigerants. Clearly, they need to play a much bigger role. They already exist, and some models use them. But there's more work to do, no doubt about it.
So, question here, anonymous one, fortunately. What can be done in built-up areas where properties are closer together and don't have the minimum distance to neighbouring properties for the air source heat pumps to be positioned? Yeah, I mean, there are some really challenging. There are other examples of that. What about flats, where it's difficult to sort of let's a large house with lots of flats in it, and individuals want to have a heat pump. Very difficult in that context, and we will need to find solutions for that. And air source heat pumps may not be that's not the only option for sure. I mean, we talked about the opportunity of sort of sharing a ground array between different properties. That could be one option. You don't need the outside space for an air source heat pump unit. But I would say let's start with those buildings where the case is relatively clear cut, scale up, and then worry about these other buildings as we go along. Because if we just focus on the difficult cases first, we're never going to get going. So I think we ought to start where it's already entirely feasible, and then there will be innovation. There will be different technologies in 10 years' time that we can't even think of today, I'm sure, because we've seen the same in other sectors. Think of solar, batteries, electric vehicles. The innovation that will happen once we scale up could be quite tremendous. Thank you. We're getting very tight on time now, so there's probably the last couple of questions here for you now. Similar to what you said about technology, Jan, do you think, this is from David McConnell, do you think that the heat pump technology is close to its limits in terms of COP, or do you think that further advancements in tech or refrigerant will provide further efficiency benefits?
I'm not a heating system engineer, but what I know is that when you look at past efficiency developments of heat pumps, they have continually improved, and they continue to be improved. And I mean, partly that is to do with the technology itself, with the kit that gets installed, that becomes more efficient. But I think it's also to do with the installation, of course. And if you install heat pumps badly, their efficiency will not be as good. If you install them very well, they have a very high efficiency. Both factors, I think, will contribute to also in the future to a better coefficient of performance of heat pumps. To what extent that will accelerate and where we will be in 10 years is impossible to say. And of course, there are thermodynamic limits. At some point, it's not going to be possible to improve that any further. But I don't think we're anywhere near that. We still have lots of potential, both for better technology and better installation.
Thank you for that, Jan. So we're going to end on one question here now from David Brown, which I think is a good one to end on. And it's, if you could implement one thing to facilitate the size and speed of ground source heat pump deployment, what would it be?
I think finding a way of providing proper finance for ground source heat pumps would be the one. It's very similar to the question about solid wall insulation, where there just isn't a sort of viable financial model for people, except for those who are in fuel poverty and can benefit from eco, of course, but even there it's very limited. So I think we will need to see something that provides a compelling financial product, and maybe pay those costs back over very long periods of time, underwritten by government. This is what in some other countries has happened. You may think of the KfW loans in Germany, where you can get a loan for almost 0% interest for very long periods of time. I think that would be the sort of thing I would like to see.
Thank you, Jan. So fingers crossed we will eventually get that. Right, well, I'd like to thank Jan for joining us today and everyone else who's come on board and watched today's very interesting webinar. And I just want to wish you luck at the White House, Jan. And
I just got a call as we were speaking, actually, which I missed.
I'm glad you put the Ground Source Heat Pump Association above the White House there, Jan.
Oh, I will.
Really appreciate that. And Jan is actually joining us at our conference on the 30th of September. I'll pop you all an email out who've attended regarding that. So if you do want to speak to Jan again and hear him talk again, that's where you can next see him with us. And so it just takes me to once again say thank you, Jan. It's been very much appreciated, and I wish you well and all the best for your upcoming meeting.
Thank you. Thanks for having me. Take care. Thanks for listening.